Right, welcome to today's lecture. So in this lecture, we are going to be discussing trigonometric functions. And in this lecture, to be specific, we're just going to do an introduction to trig. And then after doing an introduction, in the next lecture, that's why we're going to start solving proper trig functions. But in this one, I just want to give a brief introduction to trigonometry. Okay. So the first thing that I would like us to look at are the terms that we normally use whenever we are dealing with trig. So whenever we're dealing with trigonometry, there are terms which I may in other words call angles that we use. Yeah, so when you look at what is called an acute angle, so an acute angle is simply just an angle that is less than the right angle. So we know to say the right angle is simply just a 90 degrees angle. So when we say an acute angle, we simply refer to an angle that is less than 90. So any angle starting from 0 degrees up to somewhere 89 degrees, these angles in this range are called acute angles. And then any angle that is above any angle that is above 90 degrees, we call it as an obtuse angle. Any angle that is above 90 degrees, or let me say from 91 degrees to 180 degrees, or let me say 179 degrees, we call those angles as obtuse angles. Obtuse angles, let me write it properly. So these angles from 91 to 179, these are called obtuse angles. So any angle between 90 and 180 is called an obtuse angle. Then any angle that is exactly 180 is called a straight angle or straight line angle. And then any angle that is exactly 90 degrees is called a right angle or a 90 degrees angle. So this one is a right angle. Then this one is a straight line angle. Then any angle that is in this range is called an obtuse angle. Then any angle that is between 0 and, that is from 0, not really from 0, but let me say from 1 or 0 point something to 89 degrees, we call that angle as an acute angle. Yeah, so this is what I'm just from explaining. An obtuse angle is one which is greater than the right angle, but less than 1/8, of course. But there are also what we call reflex angles. So reflex angles are the angles that range between 1/8 and 360. So any angle that is between 180 degrees and 360 degrees, these angles are called reflex angles. So when we have an angle which is like this angle here, theta, is an acute angle. Then when we have a straight, a 90 degrees angle like this, so it's called a right angle. And then when you have any angle that is above 90 degrees, this angle is called an obtuse angle. Then we also have an angle that is over 180 degrees. So we measure angles starting from this side. So this angle is called a reflex angle. Yes, so it can be like this or it can be like this. So this is a reflex angle. All right, so let us quickly get into other things. So we've talked about the acute angle, the obtuse angle, the reflex angle, and then we also have what are called complementary angles. So complementary angles are simply just angles such that these are just angles that are in a way that when you add them, they'll give you a total of 90 degrees. So if you have two angles A and B, when you add these and then the answer that you get is equal to 90 degrees, these two angles are called rather complementary angles. And then any two angles that you are going to add to get, let me not use A and B, let me use C and D. So any two angles that you are going to add to get 180 degrees, these are called supplementary angles. Then complementary angles are angles that that you get after adding. I mean, these are two angles that you add to get 90 degrees angle. All right. So I have talked about supplementary and complementary. Okay. Let's look at what is called trigonometric ratios. So trig ratios are simply just the normal cos and sine, normal cos, sine and tan, you know. So when we talk about trig ratios, we're simply talking about sine theta, cos theta, and tan theta. So these are the trig ratios that we are talking about. So whenever you hear trig ratios, these are simply the things that they are talking about. So on this same part of trig ratios, let me also talk about, okay, so this is what I'm talking about. So trig ratios are simply just a sine, cos, and tan. And then when we look at this x or y plane, the y-axis is normally considered to be a sine axis, and then the x-axis is usually taken as the cos axis. So if you are reading any coordinates on the x or y plane, you read them as cos, cos comma sine. So meaning we read all the x or y coordinates as x comma y. So I said this one is cos, and then this one is sine rather. So this one is sine. So this x comma y can be read as cos theta comma sine theta. So this is how you read them. Then from there, you can have all right, so this is what we have. All right, sorry for that inconvenience. Okay, so we were talking about the trig ratios. So the x-axis is read as the x-axis is read as the the cos axis, and then the y as the sine axis. Right. So this is what I was just talking about. Okay. So now we also have to understand that tan theta can also be written as sine over cos. So every time you look at tan theta, you shouldn't just look at it as tan theta. What should come in your mind is the division of sine and cos. So whenever you divide sine theta and cos theta, the answer that you get will simply just be tan theta. So every time you divide sine theta and cos theta, you get tan theta as your answer. All right, so these are not the only trig ratios that we have. This you should understand. These are not the only trig ratios that we have. Okay, so this is what I was talking about. So in most cases, when you look at complex numbers or vectors, discover that every time you're finding the angle or the direction of a given force or anything, you discover that we always say tan theta is equal to the y component over the x component. This is where it came from. All right, so the other thing that you need to understand are the other trig ratios that, like I said, we do not, these are not the only trig ratios that we have. We also have what is known as sec theta. Sec theta, this one is just the same as 1 over cos theta. So whenever you divide, or the inverse of cos is sometimes known as sec theta. So 1 over cos theta is sec theta. Then there's also what is called cosec theta. So cosec theta is simply just equal to 1 over sine theta. There's also what is known as cotangent, which is just abbreviated as cot theta. So cot theta is also equal to 1 over tan theta. So cot theta is also known as 1 over tan theta. So let's try to replace while there's tan theta, we put sine over cos. So if we replace in cot theta, while there's tan, we put sine theta over cos theta. So if we put this while there's tan here on the denominator, when you divide this, this is just the same as 1 divided by sine theta over cos theta. Then according to the normal division that we know, this can also be written as 1 times cos theta over sine theta. So this whole expression here can be written in short as cot theta is equal to this part here, which is just, this is supposed to be cot theta, not cos theta. Cot theta can be written as cos theta over sine theta. Yeah, so in other words, cot theta can also be written as, so cot, this same cot here, can also be written as cos theta over sine theta. So these are very important in the sense that, you'll be using them when solving trigonometric equations. Then apart from that, you also need them when solving identities. Yeah, even when dealing with composite functions, rather composite, compound angles, not composite, but compound angles. All right. So let's quickly look at this. So this is what I was talking about. Cosec theta is simply just the same as 1 over sine, which can also be abbreviated as CSC. So whenever you see this or that, they simply just mean the same. Or wherever you find this, you can easily replace with that or that. It's still the same. The same applies to this part here. We have cotangent, which is cot theta. So cot theta is simply just equal to 1 over tan theta, which can also be written as 1 over, what is tan theta there, we replace with this part. We replace with that part. So we put, where there's tan, we put sine over cos, which can also be written as cos over sine. And then we also have the other trig ratio, which is sec theta. Sec theta is also equal to 1 over cos theta. So I've talked about all these. Let us look at what is known as SOHCAHTOA. So SOHCAHTOA is also is not a new term, I'm sure, for most of us. This SOH stands for, this one stands for sine, S stands for sine theta. So sine theta is equal to, the O there stands for the opposite over the H stands for the hypotenuse. Same applies to this car, which is CAH. So here we have cos, C for cos theta, then A for the adjacent, and then divide by the hypotenuse. We also have TOA there, the T for tan theta. So the T for tan theta, and then the O for the opposite, then over the A for the adjacent. So this is what SOHCAHTOA stands for. It's not something that you need to even master. This is a straightforward mnemonic word. Okay. So this is what I was just talking about. So when we look at the triangle, the hypotenuse is usually the longest part of a triangle. Then we also have the opposite to the angle. So this part is called the opposite of this triangle because it's opposite to the angle there that we have, which is x. And then this part is adjacent to, is known as the adjacent of this triangle here because it's adjacent to the angle. All right. So we have also what is known, we also have what is known as the unit circle. Yeah. So the unit circle is simply just a circle with radius 1. So let us look at this. Yeah, so like I said, the y-axis is sometimes known as the sine axis, and then the x-axis sometimes known as the cos axis. So in this unit circle, we know to say unit from the word unit. Unit means 1. So yeah, unit means 1. And then when we say unit circle, we refer to a circle with the radius that has a magnitude of 1. Yeah, so you can see this is how you read the coordinates. This coordinate here is 1, 0. We also have 0, 1 here. We also have negative, 0, negative 1, 0. We also have 1, negative, rather 0, negative 1. So these coordinates are read as cos theta, sine theta. So now, if they ask you to find sine 0, let me start with sine 0. They ask you to find sine 0. So this unit circle will help you to find some of the angles of some of the solutions for special angles. If they ask you to find maybe sine or cos 0, sine or cos 90, sine or cos 180, sine or cos of 270, sine or cos of 360. This is what you use. If you can't master them, you just use this circle which I've written here. So if, for instance, they ask you to find if for instance they ask you to find sine, they ask you to find sine 0 degrees. So sine 0 degrees is simply just going to be equal to, you look at these coordinates here. So we have these coordinates here. This is where we have our 0 degrees. The 0 degrees is there. So we have at 0 degrees, we have these coordinates, which is 1, 0. We have 1, 0 at 0 degrees. And then remember what I said, these coordinates are read as cos theta, sine theta. So if we say sine 0 degrees, sine 0 degrees is simply just 0 because what is under sine this side is 0. So the answer for that is 0. So if we say cos 0 degrees, the answer will be 1 because we read these coordinates as cos, sine, which is 1, 0. So the answer is 1. Same applies to this part. If they ask you to find sine 90 degrees, so sine 90 degrees is simply just, you read these coordinates. Remember I said you read them as cos, sine. So cos for 0, 0 for cos, and then 1 for sine. So if they say sine 90, the answer will be 1. And then cos 90 degrees, the answer will be 0. This is how it is. Same applies to this part. You do the same. If they ask you to find sine 180 degrees, so sine 180 degrees simply just be 0, then cos 180 degrees will simply just be -1. So it's a very important circle that will help you to find some of the solutions to trigonometric ratios. So now, what if they ask you to find tan 0? So tan 0 degrees, how do you find this one? Because we don't have tan here, we're just dealing with sine and cos. Remember what I told you? I told you that tan theta can also be written as sine theta over cos theta. So when they ask you to find tan 0 degrees, you just have to divide what you've been given there at 0 for sine and for cos. You divide the solutions that you have for sine and for cos. So tan theta, we said it's equal to sine theta over cos theta. So sine 0, we said sine 0 is equal to 0 there. Then everything divided by cos 0, the answer is 1. So 0 divided by 1, the answer is 0. So tan 0, the answer is 0. If they ask you to find tan 90 degrees, tan 90 degrees, this is just the same as sine 90 degrees over cos 90 degrees. So remember, we're dealing with special angles here. We're not dealing with these other angles like 32 degrees, 29 degrees. No, I've not yet started touching those parts. We're just dealing with special angles that are in a unit cycle. Okay. So from there we have, I said tan 90 will be sine 90 over cos 90. So what is sine 90? So sine 90 degrees is simply just equal to 1, then cos 90 is 0. So we say 1 divided by 0, which is just equal to undefined. So tan 90 degrees does not exist, in short. It has no solutions. Okay. Let's quickly move on to the next part, the next segment. Or before we can proceed, do you have questions? Okay, so if you don't have questions, we are well to move on. Okay. Right, so this is what I was just talking about. Okay, let's look at solutions of special angles. So when we talk about special angles, we're simply talking about 0. We're simply talking about 30 degrees. We have 0 degrees. Let me write them here. We have 0 degrees. We have 30 degrees. We have 60 degrees. Oh, I've forgotten one. There's 45 as well. So we have 45 degrees. Then we also have 60 degrees. Then apart from that, we also have 90 degrees. So these are the special angles that we're going to discuss. So to find the solutions of these angles, sometimes they can ask you to find sine 30, sine 45, or maybe cos 60 or tan 90. How can you find that? So what I'm giving you right now, if they don't allow you to use a calculator, this is one of the key points that you need to get if you don't want to be stressing when finding such angles. Okay, so the first thing I'm going to do is I'm going to write numbers starting from 0. So I'll write 0, I'll write 1, I'll write 2, I'll write 3, and then I'll write 4. So after doing this, I'm going to divide everything by 2. So I'm going, before I do the division, let me first square everything. I'm going to square 0, I'll square 1, I'll square 2, I'll square 3, and I'll square 4. So when I square 0, my answer is 0. And I square 1, my answer is 1. The square root of 2, the answer is the root of 2. This is an irrational number, so we can't express it in decimal. So, I mean, we can express it in decimal using a calculator, but not just without a calculator. Same applies to the root of 3, so I'll leave it like this. Then the root of 4, the answer is 2. So after finding these answers, I'm going to divide everything by 2 like that. Then after dividing everything by 2, the solutions I'm going to get to be 0. Then I have half there. Then I have the root of 2 over 2. Then I have the root of 3 over 2. Then I have 1 there. So the solutions that I've gotten here are solutions for sine theta. So if, for instance, they ask me to find sine 0, the answer is 0. Sine 30, the answer is half. Sine 45, the answer is root 2 over 2. Sine 60, the answer is root 3 over 2. Then there's also sine 90, which gives me 1. So this is also one of the important things that you need to master. Then for cos, we're going to write cos here. So for cos theta, I'm going to write everything here. I'm going to write everything that I have under sine. Starting from this side, I'm just going to flip this. So I have a 1 on 90. I'm going to bring this 1 here. I have root 3 over 2. I'll write my root 3 over 2 there. Then I have root 2 over 2. I'll write root 2 over 2 there. Then I have 1 over 2 there. This 1 over 2 here, I'm going to write it here. Then I have a 0, which I'm going to write there. Okay. So this is exactly what you're supposed to do. So if they ask you to find sine 0, the answer is sine 0 degrees, the answer is 1. Sine 30, not sine 0, rather, cos 0 degrees, the answer is 1. Cos 30 degrees, the answer is root 3 over 2. Cos 45 degrees, the answer is root 2 over 2. Cos 60, the answer is 1 over 2. Cos 90, the answer is 0. So this is how you find solutions of special angles. So now, how about tan? How do we deal with tan? Remember what I told you? Tan theta is just the same as, so we said, okay, all right, I'm here. So we said tan, okay, so we said tan theta is simply just equal to sine theta, or let me write it down so that you understand slope profile. Okay, so we have tan theta here. Tan theta is equal to sine theta over cos theta. So what is going to happen is that I'm going to be dividing these numbers. So sine theta, if I want to find tan 0, I'm just going to divide sine 0 over sine 1, which is just going to be 0 divided by 1. So 0 divided by 1, the answer will simply just be 0. So if I divide, for instance, want to find tan 30. So tan 30 will simply just be sine 30 over cos 30, which is just going to be the same as dividing half by root 3 over 2. So half divided by 3 over 2, the answer is simply just 1 over the root of 3. So this will give me 1 over the root of 3. And then if I divide, if I want to find tan 45, I'll divide this, divide by that, which will just give me a 1. Then tan 60, if I want to find tan 60, I'll divide this, divide by that, which will give me the root of 3. If I want to find tan 90, I'll just divide this 1 and that 0, which will give me undefined. So this is how you find solutions of special angles. So remember the first step which I took, I first wrote numbers from 0 up to 4. And then from there, I square rooted all the numbers. Then afterwards, I divided every number by 2. Then after dividing all the numbers by 2, the solutions that I got were the solutions for sine theta. And then to write the solutions for cos theta, I simply just wrote the same solutions for sine theta, but in the opposite way. I started with the last number. The last number this side is the one that became the first number for cos. Then to find the solutions for tan, I simply just divided sine theta and cos theta, and then found these answers. Right, so this is what I was talking about. So these are the solutions that I was talking about. Okay. Let's quickly move on to trig ratios. We talk about the quadrant. So when we talk about the quadrants, we are going to draw the XY plane. I'm going to draw the XY plane. So all the trig ratios in the, so this one is first, this one is called the first quadrant. This one is called the second quadrant. This one is called the third quadrant. This one is called the fourth quadrant. So all positive angles lie in the first quadrant. So every positive angle is also found in the first quadrant. All positive angles are found in the first quadrant. All angles, in short, they are all in the first quadrant. So as long as it's positive, then it's in the first quadrant. So here we say all trig ratios in short. Let me not say all angles, but all trig ratios, because in the first quadrant there we have all trig ratios. We have cos is positive there, cos theta is positive, sine theta is positive in the first quadrant, even tan theta will be positive in the first quadrant. So this may not make sense to you today, but the next time we're going to have a lesson, these things are going to make sense because we're going to be solving questions which are going to be involving quadrants. Okay, so in the second quadrant, it's only sine which is positive. So sine theta is only positive in the second quadrant. In the third quadrant, it's only tan is positive in the third quadrant. Tan theta is only positive in the third quadrant. And then in the fourth quadrant, only cos theta is positive. So what this means when you say sine theta is only positive in the second quadrant is, what this means is that cos theta in this quadrant is going to be negative, and tan theta in the second quadrant will be negative. In the third quadrant, sine theta will be negative and cos theta will be negative, but tan will be positive. In the fourth quadrant, sine theta will be negative and tan theta will be negative. Only cos is going to be positive. But in the first quadrant, all the three trig ratios are going to be positive. That's what it means. So you understand this better when we solve maybe one or two questions. So this is exactly what I am talking about when I talk about the quadrants. Okay. So all trig ratios are positive in the first quadrant. In the second quadrant, only sine is positive. In the third quadrant, only tan theta is positive. And in the fourth quadrant, only cos theta is positive. All right, so these are the angles that we are talking about. Yeah, I also forgot to talk about one very important aspect of these quadrants. Okay. Okay, let me just talk about it here. So in the first quadrant, if you're solving an equation, then you find your solution to be positive. In the first quadrant, you take the value for theta to be that same answer that you have gotten. And then in this quadrant, in the second quadrant, you take the value of theta to be 180 degrees minus the value of x that you have found. So in other words, we're trying to find this theta. The answer that you've just gotten after solving the equation is this one, this x. So now to find this theta, we're going to say this 180 degrees minus x, we're going to remain with theta there. So you can just master this to say in the second quadrant, you always find theta by subtracting x, or by subtracting the answer that you've gotten from 180. In the fourth quadrant, you're going to say 180 degrees plus x to find theta. And then in the fourth quadrant, you're going to say 360 degrees minus x for you to find theta. All right. So this is just as simple as this. Yeah, so let's quickly move on to the next part, if this is not the last part we're talking about today. So today I just wanted to introduce trig, and then in the next session we're going to do a lot of solving. We're going to solve a lot of different equations, and yeah, we're going to solve a lot of different equations in short. Then apart from solving, we also have to go further by looking at compound angles. Yeah, apart from compound angles, we also have to look at how we can sketch trigonometrical equations. How we can sketch the graphs of trig functions. Yeah, so we're going to look at all that. Okay. So this is what I was talking about. We have 180 minus x, 180 plus x, then also have 360 minus x. So this is what I had for today. I prepared it to be a short lesson so that at least you can have at least full knowledge about what we're going to start looking at. So in the next session, that's when we're going to start solving equations, and we'll also look at identities. And then apart from identities, we'll go further by also discussing the compound angles and And we'll also look at half and double angles if that is also part of the, your syllabus. All right, thank you very much for attending tonight's lesson. If you have any questions in this last 2 minutes, you can tell me to go back so that I explain.
Sir, I think, hello?
Yes, I'm getting you.
Yes, you sent this recording as quickly as possible before we forget, so that we can start going through, we can go through again.
All right, I'm sending it right now immediately. I just end the session. All right, thank you very
Yes, sir.
much.
Thank you.
Yes, we're going to meet in the next lesson.
Thank you.
Okay.
Thank you.
Thank you. Wow.